Okay, hello everyone. Hello again. So what I want to do here is for Lab 2 in the Sim 655 course, what I want to do is go through the setup of the Mechatronics Concept Designer part of the lab. So we kind of begin here. So we've got the Mechatronics Concept Designer model of our pick and place hardware. And as I've kind of mentioned before, it looks kind of funny in that I've blanked out some of the components, especially of the housing for the gripper. That's just so we can see the sensors operating. Okay, so we've set up a number of components that will move during the simulation. These, I think in class I went through how to properly set these up. We have, so there's the different rigid bodies in the simulation. We also have different joints and constraints that are here. So that's those two. Those should already be existing and be working. Then we also have a number of sensors and actuators. So this is what I'm talking about here. We've got sensors for the gripper. So I've got two. One is the not open sensor. That's because, and I had to resort to this because of the geometry that came with the Festo gripper model. So not all of the geometry was there, so I had to create this not open sensor. So you'll see it's tripped right now because the gripper's in the closed configuration. So that's the right attached with the right. Then there's the left, and it's closed, so that's actually also true. Then we have the proximity sensor for the left. Okay, that's working here. So it's sensing, etc. I mean, I have also they got the right sensor, that's over here. Then we've got the left sensor, the down sensor, and then the up sensor. Okay, and then the corresponding sliders there. Then we also have associated in the operations manager, we also have a set of operations which control the motion, or the motion of these different actuators. Okay, so we've got all this should already be existing. So what I want to do now is prepare this model for operation by a Node-RED set of flows. So the first thing to do is in this electrical area, we want to set up a symbol table. So this is a set of all of the symbols or variables that will be exchanged with the Node-RED flow. So let's just call this pick and place as the name of the table. And I create a new one. Let's create all of the outputs. So in this the way we've got this working is the simulation here, the Mechatronics Concept Designer, is simulating the actual pick and place hardware. So outputs from the hardware are all of the different sensors, and the inputs from the PLC, from the PLC would be the signals to drive the different actuators. Okay, so let's create the outputs. And what I'm going to do is I'm going to use this convention where I create this as a signal. So I use the word signal underscore, and I'm going to call it open limit. Okay, for the gripper open. Okay, then I'll create, and that's an output, and the data type is Boolean. Whoops. Let's go back. So one more time. Signal underscore open limit return. Okay, let's create another one. Signal underscore close limit. Also an output, hit return. Another one. Signal underscore, let's go down limit, return. Signal up limit. And last output is signal underscore right limit. Okay, now I'm going to create a set of inputs. So these inputs are the signals that then drive the different operations here. So I'm going to create another symbol. I'll call this signal underscore close gripper. And in this case, I'm going to now make it an input. Signal underscore open gripper. Also an input. And signal moving down and input. Signal moving up, up as an input. And finally, signal underscore moving right, also an input. Okay, so these are all the symbols now that we're going to use, that will be exchanged between the two devices. So then you can see here, I've got a symbol table here, right there. Now, the next thing to do is then to create a signal adapter. So what this does is it when the signal comes in, let's say from the node red, it tells basically Mechatronics Concept Designer what to do with that information. And then the other thing, when the new signal information is generated by Mechatronics Concept Designer, it tells it which signals to use. So we use this signal adapter. Okay, so let's select the first one. Let's go with let's go right here to the gripper not open. Okay, so we've selected that. We're going to add a parameter here. And sometimes you have to carefully select the right spot. It's not always cooperative. Let's maybe move this open. The parameter we're going to use is the triggered parameter, and I need to change the name here. Let's click off it. There we go. So MCD, MCD. So again, for the signals, I was using the signal the convention here. Now this is an MCD, and this is a gripper not open. Let's call it that. Okay. Oh, and I have to hit return, so let's click off it. MCD underscore gripper not open. Return. There we go. Okay, let's create another one now. Let's come here. We're going to select a different sensor now. So let's select the left gripper closed, and we'll create a new parameter. MCD underscore gripper closed. And again, we'll use the triggered parameter. Okay, let's go with another one. Let's go for the down. Okay, create another one. MCD underscore down limit. Okay, let's do the up limit. MCD underscore up limit. Okay, let's try and then the left limit, and a new parameter there, MCD underscore left limit, and then the right limit, which is here, and a new parameter, CD underscore right limit. Oh, and so just before I forget, all of these should be the triggered parameter. Okay, now the signals. Where are we going here? Okay. So for the signals, are we going to open limit? Okay, hold on. Let's X out of that one. Okay, so we've got the open limit as the first signal. We're going to assign that, and then we're going to, in the signal, the open limit, remember we have this gripper not open, so we have to enter a formula here. And we're going to use the if formula. Let's find an if function. Or MCD. Okay, let's use the math. Okay. Conditional. That's what I want. So if, and I want to enter that MCD underscore gripper not open. If that is true, then I want to make this one false. False. Else, if this is false, then I want to make the signal true. Okay, so there, I've assigned the output limit signal to this formula here. Okay, oh, and I'm going to call this pick and place adapter, by the way. Okay, so let's now add another signal here. In this case, I want to use the signal underscore, I believe it was gripper close. Okay. And actually, is there a way? And I'm just going to make that equal to now the MCD gripper closed. So if I just go C here and then I type that in and hit return, then the signal gripper close is just equal to whatever the state, the triggered state of this gripper closed is. Okay, then the other ones I will do yet another one here, signal down limit. Okay, and I'm going to assign that here. I want to assign it to this one, MCD down limit. And I just paste that into the formula. Okay, let's make a new one, signal. Up limit, assigning it to this parameter. And hit return. A new signal. And assigning that to this parameter. And one more signal here. Right limit. Okay. And assign that again here. And it doesn't look like, yes, okay, that doesn't actually appear. So I have to come here and just copy this into the formula. Okay, so I've assigned each of these signals here. Open limit. Let's go with closed limit there. Right, down limit, up limit, left limit. Okay, so that, yeah, I had just gotten the wrong signal there. Okay, So that's our adapter. Okay, so let me block this up again. So we've got our signal table, then we have our adapter that says how these signals are used within MCD. Now notice that I only included the outputs. The inputs need to be included in these operations here because the input signals actually control the motion of the different components, which is controlled by these operations. So let's look at the right gripper open here. We double click on that. Right? And what we want to do is we're going to add a condition. So let's first of all okay, let's select an object. And what we want to do is select one of the signals. And what we probably need to do actually is add these signals to the adapter. So let's go ahead and do that. Let's go signal, close gripper, and that's an input. Close gripper. Let's create another signal here, also an input. Open gripper. Another signal. Moving down. Moving up. Moving left. And moving right. So now when I save this, and I'll close these, and then open up the adapter, then I can see all those. So now I go back to my operation, and the condition object that I want to use for this is the gripper open, the right gripper open, is I want to use this signal open gripper. Okay, and I'm going to open the right gripper finger when I get a true from the node red simulation. So when this signal open gripper is true, then I want this operation to execute. Okay, so you'll notice here now the operation turns blue. Then and also this tag here appears. The left gripper open, let's do the same for that. Again, I want the open gripper condition. Sorry, I want this. And then the open gripper. Oh, let's cancel. Try that again. Left gripper. I want to highlight this select condition. Then I want to use the open gripper. Let me see. Okay, I think I have to make some fixes here. Okay, let's change this to true. So whenever the left gripper, to open the left gripper, I need to receive this signal, open the gripper. Okay, then closing the gripper, double click that one, highlight the select condition, and then there should be a close gripper right there. And I want to make that only execute this operation when I receive a signal, close the gripper. Okay, Then right gripper close, same idea, close gripper, and make that only execute when that is true. Okay, x-axis left, I want to execute that when I get a signal moving left. And I want to make that, I'll move left when I get the signal to move left is true. Right, I want to choose the moving right and also make sure that's true. Then up, I want to make that moving up and make sure that's true to move up. And then moving down, again, the condition will be moving down true. Okay, so all of those operations now are tagged. Okay, they're connected to the signals, which are here in my adapter. Okay, so let's save that. Okay, now the last thing you need to do in Mechatronics Concept Designer is to connect to the server. But before you can do that, you have to set up a server in Node-RED. So if I come over here to Node-RED, and we set up this, so in Node-RED you should have this palette OPCUA, so there's some instructions on how to get this palette and how to install OPCUA in the Node.js. Okay, so you need an OPCUA server here. So you would click and drag that one out here. And the port number I tend to use something in the 48,000 region. Okay. The name or the endpoint is opc.tcp : // so just like a web address, except we're using the OPC rather than HTTP. And then localhost, which means that the server will be running on this PC that I'm using. Okay, so we set that to done. Then what I do here is I create a set of triggers. So that comes here from here, the inject nodes. Okay, and what I'm doing is I'm adding onto the server these different tags or different variables that we'll be using or exchanging between Node-RED and the MCD. So again, I have to create these on the server. So for each of these here, in the message payload, I have within the curly braces this, in quotes, OPCUA command, and then a dot, and then add variable. Let's see if I can make this wider. Yeah, there we go. And then, sorry, not a dot. This is a colon, and then add variable. Now if I click down here, yeah, okay, you can see it even better here. Okay. Okay, and then the message topic is namespace 1, string moving left. So that's the name of the variable on the server that I'm creating. The data type is Boolean, right? It's either moving left or true or false. And then the initial value is true. So for all the actuators, I add a value or an initial value. Okay, and then last down here, I inject once after 5 seconds, and then no repeats. Okay, so that's that. And then I create one for each of the actuators, and then one for each of the signals. Now for the signals, again, it's the same OPC UA command add variable. Here it's the left limit, that's the string, and the data type Boolean. Okay. So if I deploy this flow, okay, and I get this running condition here for the server, I can now connect to it with Mechatronics Concept Designer. So let's check that out. So I've created this 48020 port and then on the local host. So that should appear in MCD. And the way we do that, I think it's external, sorry, here, external signal configuration. Okay, so what we want to, we're using the OPC UA type of external signal exchange. And I've already got this set up, so let's maybe create one from scratch. So I will come over here, add a new server, and it will be localhost : 48020, and I hit return. Okay, so I've connected to this server before, so I can view the certificate. Okay, and so this is actually information. If you have never connected to your own computer before through MCD, it will ask you to put in some names and so forth. So I think some of this, yeah, the common name. There may be some other things here that you need to fill in. I'm sorry, I don't have that information here. Now we can test the connection. That's the other important thing, and it's connected to the server successfully. So if I click OK here, there. Now the other important thing to note here is when I look at this, I can see all of the variables that I've created. So I want to use those, or I want to look at that, all of these. So moving left, moving right, up, down, closing grip, opening grip, left limit, right limit, up, down. Oh, these are the moving, and yeah, so I want to interact with all of these. So these are going to be inputs, and the limit switches are the outputs. These last two I don't include because I'm going to use those. I use those with Node-RED, not with MCD. Okay, so then we go click OK there. Okay, and then last but not least, we have to do some signal mapping. Okay, so here's my OPC UA server. There's my local host 48020. And I've got a signal open limit here. And I want to associate that. So these are the signals that I created in my signal table. And I want to associate that with one of these variables on the server. Okay, so open limit, I want the open limit variable, which is right here. Okay, so then to do that mapping, I click on this middle map, the signal. Okay, so I have the MCD signal open limit, and that's on the server open limit. Okay, next one, close limit, that's here. Create that signal connection. Down limit here, that one. Up limit here, left limit here, right limit here. Close the gripper, closing grip. Open the gripper, opening grip. Moving down, moving up, moving left, and moving right. Okay, so let's check, just do a check. Okay, so it's all a one-to-one connection, and the direction, we can check that. So the signal left limit, that's going to the server. And then these other ones, closing and opening, those are coming into MCD. Okay. So then now we're ready to go. All right. So then if we add these other, where's my node red? If we go to the dashboard, okay, in order to run this, we have to, first of all, get enough screen so I can see both of these. So I'll move this a little bit further to the left. There we go. And now move the Mechatronics Concept Designer a little to the right. Sorry, a little to the left. Whoops, went right off my screen. There we go. There we go. Jeez. Sorry. Okay, and then to actually get this to run, now I've deployed the flows. So to actually connect the two, I have to play. And here, what I've set as the initial position is all the way to the right. So it moves over there. And then, so I've got my home is now defined on the right here. Left limit is false, right limit is true. Up limit is true, down limit is false, close, true, open. Okay, so first thing, I can open the gripper. So I'll turn close gripper false and open gripper true. You can see the gripper goes down, gripper opens. Then I can change the moving up to false and moving down to true. Okay, and I should be, actually while I'm doing this, I should be checking the telemetry as well. So close limit is false, open limit is true. The down limit is true and the up limit is false, which is what I expect. And then let's change moving right to false and moving left to true. Okay, and so there's my telemetry there. So left is true and right is false. Okay, so that's the basic how we connect the two together. Okay, thanks for listening.